today we start calculus, chapter 11, Introduction to Differential Calculus, and we're going to talk about rates of change. How do we find rates of change? And this should be a breeze. This first introduction should be a breeze. So what is calculus? It's the mathematics of change, velocities, accelerations. We have tangent lines, slopes, areas, volumes, arc length, curvatures that model real-life situations. Anything that's dynamic, anything that's changing. In pre-calculus, we were able to calculate an object traveling at a constant speed. And in calculus, we can analyze the velocity of an accelerating object or a decelerating object. In pre-calc, we found the slope of a line. In calculus, we find the slope of a curve. And pre-calculus, you can find the tangent to a circle. And in calculus, we find the tangent line to any graph. So this is from your textbook. If you think about filling up these shapes with water, you can see that as time is passing, the depth of the water is increasing. In a cylinder, it's increasing at a constant rate. But what if we change the shape of our glass and now it looks like this? And the radius is changing of that circle. As it goes up, it's getting greater. So that means the depth, the height of the water in the glass is going to be increasing still, but at a slower rate. And for a challenge, you can examine these. This is from your book. These shapes of the glass and see if you can draw a graph that would represent the height of the water over time. That's the kind of stuff that's super hard for my brain. Good challenge. A rate is just a comparison between two quantities with different units. Runs per inning, points per game, miles per hour. The word gradient is used to describe the slope. They are the same. The textbook and the IB curriculum uses the word gradient for slope. And just to review, your slope formula is change in y over change in x. Here's an example. The average length in centimeters of a baby over time in months is given by the graph below. Find the average rate of change between the second and the fourth months. So if we go find the second and the fourth, we're going to estimate these 2 points. So this is at over 2. So this is 2, 4, 6, 8. 58.5, and this is over 4, 62, 4, 65 maybe? And maybe I'll just call this 58.9, just to make it a little bit easy. Oopsie, just to make it a little bit easier. And then we're just going to find the slope. So we're going to do the change in y's over the change in x's. Three centimeters per month. Let's see if it changes. If we look at finding the average rate between the 8th and the 12th month. And the 8th would be 8, this looks like it's, let's estimate it to be 71. And the 12th is estimate to 475 centimeters. So 75 minus 71 over 12 minus 8. And now all of a sudden we have 4 over 4, so that's about 1 centimeter per month. And so you can see that this baby is not growing at a constant rate of change. Between the second and the fourth month, it's growing much quicker than between the 8th and the 12th month. You can see that it's changing. Here's another example. Consider the function 4 minus x squared. Find the average rate of change in f of x from 2 to 3. So here's our point 2 to 3. We want to find the rate of change. So what I'm going to do is do f of 3 minus f of 2, all divided by 3 minus 2. F of 3, I can substitute 3 into my function, so I get 9 minus 4, which is 5. F of 2, I can substitute 2 into my function, and I get 0. So I get that the slope from 2 to 3 is 5. I'm going to do a similar thing here from 2 to 2.5. I'm going to do f of 2.5. I'm just looking at my work. It should be negative 5, right? Because f of 3, this would be a negative 5, because that's going downhill. And then I'm looking at 2 to 2.5. So our slopes are going to be pretty similar. And I can find f of 2.5 by substituting it into the function. So I'm going to do 4 minus 2.5 squared. And I got negative 2.25. And then I'm going to substitute 2 in, and I get 0 again. And then I'm going to do negative 2.25 divided by 0.5, and I get a slope of negative 4.5. And the final one, I'm going to do f of 2.1 minus f of 2 over 2.1 minus 2, which is 0.1. I can substitute 2.1 into x squared, so 4 minus 2.1 squared, and I get negative 0.41 minus 0, divided by 0.1, which is negative 4.1. So you can see I'm estimating the slope as the distance from 2 gets smaller and smaller. Instantaneous rate of change is the slope of the tangent line. So a tangent line is a line that touches the graph at exactly 1 point, whereas the secant line intersects the graph at 2 points. And the secant line helps us find the average rate of change. The normal line we'll talk about later. It's perpendicular to the tangent line, but I just wanted you guys to see them all together in one graph. So now if we look at the same function and we're asked to find the instantaneous rate of change at 2, we draw a line at 2 that touches the graph at 1 point. So it touches the graph right there, and we can find or estimate the slope here by finding another point on the line, the green line, and just finding the slope. So this looks like it's so 2, 0 is a point, and maybe 1, 4 is a point. So if we do 4 minus 0 over 1 minus 2, we get 4 divided by negative 1, which is negative 4. Just want to take you back to the example that we did with the secant lines here. And as we started out by going from 2 to 3, and then we moved it from 2 to 2.5, and then we got closer to 2 and did 2 to 2.1. And as our distance between the 2 points got closer and closer and closer to the actual tangent line, you can see what happened to the slopes. We got negative 5, then negative 4.5, then negative 4, and then the slope of the tangent line is negative 4. So you can see that these numbers were approaching negative 4. We'll talk about that in the next section. Find the instantaneous rate of change, same function, but now I moved the point to be at 1. So this point is at 1, 3. Find another point on the graph here. How about 0, 5? Find the slope. 5 minus 3 over 0 minus 1 is 2 over negative 1. So the slope is negative 2. The instantaneous rate of change of 4 minus x squared at x equals 1 is negative 2. All right, that's it. Start your homework.